Record. Good morning to everyone present here with warm greeting. It gives me a great pleasure to extend warm welcome on behalf of Kalasalingam Academy of Research and Education under the Department of Computer Application, conducting the workshop on 5 days workshop on hands-on education on real-world machine learning. Today is the day 2 under the topic machine learning tools and frameworks by the resource person, Dr. Sridhar sir. He is the professor in SRM Institution of Science and Technology, and happy to welcome. He is an alumnus of Arundu Kalasalingam College of Engineering, which was under Madurai Kamarajar University, and did BE in computer engineering during the period from 1986 to 1990. And then he did Master of Science in Computer Software System from Birla Institute of Technology and Science. And his research in area of constructive neural network from SRM University in 2014. And he became a teacher in Department of Computer Science and Engineering from June 1990. He is specialized in brain-computer interface, pattern recognition, deep learning, teaching undergraduate and postgraduate students, and guided some good number of projects in domain of brain-computer interface, neural network, pattern recognition, and image processing in his year of 32 years of teaching. He has a good number of publications in international journals and conference. He has authored 2 books, namely Proceedings of International Conference on Internet Computing and Information Communication under the publication of Springer, and Computer Practice for first year BTech students. He coordinated the Wipro Mission 10X faculty empowerment program, which offered training to more than 350 faculty members from SRM University and its sister's institution. And he served as a chairman of IET, Chennai Local Network, it called as CLN, spearheading on one of the largest local network in South Asia. And also he has developed some in-house software like admission counseling software, feedback software for assessment of teachers under in SRM University, medical expert systems for SRM providing urban amenities in rural areas. And also he involves in societal programs and spoken in many forms like workshop by Pudhiya Talamurai Foundation, Valikati program organized by Dinamallar, adapting a government school at Katankulathur to offer computer literacy training for school children. I proudly warm welcome, sir. And also I welcome our beloved HOD, Department of Computer Application, for his continuous support to conduct the webinar. I welcome you, sir. And also I welcome our Dean ma'am, Deepalakshmi ma'am, for his continuous support to conduct its workshop. And also welcome for all students are well registered for UG and PG and research scholars and registered from other colleges also. So I welcome all of students for connecting this workshop. Welcome you all. So welcome, sir. Shall we start proceed our workshop, sir?
Yes, yes, madam. Thank you. Thank you for the very good introduction. Am I audible?
Yes, sir. Yes, sir.
Fine.
I stop my
very good morning. Okay, fine. So very good morning to one and all. Very, very happy to connect with my alma mater. I did my BE from Arulmigu Kalasalingam College of Engineering, that is your university, in 1986 to 90. So I did my BE there. So that is the second batch, actually, you can call it as. So very happy to connect with my college back again after 32 years, because I don't come for alumni meet and other things. I'm stuck up with the teaching job itself. I'm here for the past 32 years in SRM. My area of interest is basically pattern recognition, machine learning, and specifically on brain-computer interface. So today we will talk more on, maybe I'll switch off the video so that my streaming will be very good. Hope this PPT is visible to you, madam.
Yes, sir. Yes, sir.
Yeah, fine. So today we will talk about machine learning tools and frameworks with very specific applications I wanted to share with you on cognitive science and disaster management. So this talk will be actually covering these concepts. Maybe I'll just list down some of the agenda points today. All of you are very familiar with the data. Anyway, I will be just highlighting of what is the data and what is the fundamental behind data. Concepts of learning, why we have to learn, and what are the concepts, and what are the approaches actually. There are basic steps to follow for learning. And what are the machine learning fundamentals and its methods. Okay, so that will cover the fundamentals of machine learning and the tools and other things. Those frameworks, we'll try to use it in two applications today. One is on the human cognition. So cognitive science is basically a fantastic field where we need to explore a lot in terms of analyzing, recording, and then recording, analyzing, and then use it for classification and other problems. So we'll talk about human cognition, then very specifically brain-computer interface, that's called BCI. What are the techniques and devices used in BCI? What is brainwave, and some case studies. I will show some results of case studies of the students which they did projects and research in this laboratory. Actually, I'm heading one laboratory called Brain-Computer Interface Laboratory in our university. We will also touch upon another application that's called disaster management, where we have very plenty of need. Actually, they need people to work on machine learning. So I will throw some light on disaster management. What are the tools and simulation model what we did? That is also a model which we built by students. The last point will be, like, I have some tips for all the students and research scholars. So just hold on till my end of the talk. To start with, so what is the data? Okay, I'll just start with some fundamentals for 3 or 4 slides. So the data, if you see on the left-hand side, the data is basically nothing but a raw fact. Okay, so without any context. When you don't have any context, the data does not have anything. So unless if you attach some context to it, that is the information on the right side, then it becomes meaningful. Okay, so information is you derive something, okay, from the facts. Then you put some more subjective elements into the thing, then it becomes a knowledge. Okay, so knowledge is actually that is what machine learning and other tools are doing. So when we don't have when we are actually putting the data into an information and also deriving knowledge out of it, that's called mining, and we do a lot of things using machine learning techniques. Then one more thing is that's called wisdom, where upon the knowledge we try to take decisions based on the already acquired information, and also it is objective basically. Okay, wisdom is basically objective. That is the highest level of the thing. So when we plot this, where the x-axis is actually understanding level, and also the y-axis is basically context independence. Okay, so when the data understanding keeps growing, then the data becomes information at some point of time, and you understand the relations, that becomes information. Then when you understand the patterns, you get knowledge. Then you understand the principles, you get wisdom. So this is how with respect to data independence and understanding goes. So very, very beautifully pictured here from data to wisdom. Now there is one more concept called hypothesis. So when you make a prediction, so if you have guessed something, suppose the IPL is going to be there, so who is going to be the winner? If you are able to predict, or what is the share price of the company next week, all these are predictions. So when you are able to predict something, that means you have made a hypothesis. Okay, hypothesis is something you make a prediction based on some facts on in data available. Goals of learning. So why do we have to learn? Okay, so because we wanted to improve the quality of communication and decision making. Decision making anybody can do with the data or information, but when you want to do some quality decision making, then you need to learn something. So what do you mean by learning? Human beings, we learn from the environment. Every day we are learning. We don't say that a human being is very 100% perfect. So every day we are learning. So this learning happens, and then we take decisions. Okay. So this these are the goals actually to make the learning happen. First, you have to build a hypothesis and verify the hypothesis. Then discover the patterns from the data. Then you predict the behavior. So that is a process here. There are two approaches. One is top-down approach and bottom-up approach. Top-down, very famous. You generate some ideas, then develop some models and validate the models. Okay, that is a traditional approach. Top-down in the tree format. Okay. So bottom-up approach is basically from the bottom level, you first collate or the group all the patterns together, which are unknown, then find out a new pattern or discover some new patterns out of it. Then you are from the patterns, you can form the relations. When you are finding the relationship, then that means it is a bottom-up approach. For example, one example I'm just giving you. Suppose I make a statement like this. Visitors coming to some mall. Okay, I mentioned some mall, EA mall in Chennai. Visitors coming to a mall earn a monthly income of 50,000 rupees. It's a very vague statement. Okay, nobody actually, we cannot validate this statement unless it is proved with some facts. We have to collect the data of overall visiting the malls, then prove this hypothesis. Somebody has made this statement, but we have to query the database and then prove this hypothesis. That's basically a top-down approach. Bottom-up approach, for example, there is a statement called men who buy cell phones also buy cell phone cover. So that is a prediction because this has been proved. Okay, because from the facts, from the patterns what you have, it is very easy to derive a hypothesis here. So this is a bottom-up approach. Okay, so there's no mention about women or anything, but men who always buy cell phone also buy a cell phone cover. Mostly 70 to 80% it might be true. Okay, so that is a bottom-up approach. Now, why we have to learn? So, for example, we need not build a system which calculate payroll. Okay, why we have to learn from payroll? Because payroll is something from the data which is available, we are going to print a pay slip. That's all. So nothing more to learn there. Only when there is absence of human expertise. Okay, for example, you're navigating to Mars, then there is no knowledge about it. We don't know. We have to explore it. Okay, when something is not able to be explained, speech recognition and all, where solutions in time. Okay, solution changes in time actually. When there is a change, dynamic change in the network, then we need to learn. Then solution needs to be adapted to a particular case. So user biometrics, we use this learning concept. Then once we collect the data, this is the process. I'm not going to the depth of all these things, but many of the things you will be learning in data mining or a basic fundamental course. So the first process would be to collect the data and clean the data. Okay, so it is not like humans. Humans, we take all the junks through our various senses and then we filter it and then we develop a knowledge. But for a machine to learn, machine is nothing but a program or an algorithm which does this learning. So for that machine to learn something, your data must be perfect. So we have to clean the data first, then integrate all the data, which is maybe high homogeneous data or heterogeneous data. Then transform the data to something which is learnable, reduce the data so that, see, we don't have to train all the data. We need only a small portion of the data to be trained. So data reduction. Okay. So all these are processes of data analytics. Okay. So what is now coming to machine learning? Machine learning is nothing but a program, okay, to optimize the performance criteria using some example data or past experience. Actually, the basic goal is to build some systems which can adapt and learn from experience. So if you look at the diagram on the right hand side, if you see, without machine learning, what we do is you have some instructions shown to the system, then you provide some data from outside, then it works based on the instructions. Now, what we are doing in machine learning is we are feeding both the input and output. That is, the data is given. From that, the machine is actually deriving the logic, deriving the algorithm or model. Okay, it is actually modeling the input-output relationship in the form of a model. Okay, so that is the difference between a traditional machine learning and traditional programming and normal machine learning programming. So machine learning can be done using classification, clustering, or regression. So we'll talk about that. What is class? Before going into that, we should know some of the terminologies here. So if you see, data mining is also a part of machine learning. We have to do some mining. Mining is actually extracting the knowledge out of the data. So there are tools, various tools available nowadays. You don't have to learn a language to do all these things. Everything is now coming as a package. So I would urge people here to just learn at least one language. In those days, people used to say, please learn C language. But nowadays, the trend is basically you learn Python. Okay, Python has become a de facto standard. And please learn Python. Python, you can learn it in just 1 week. There are courses available, online courses available, free of cost, or PPTs available, or YouTube videos are available. Please watch and learn Python very well. It is a very, very easy language. And it is very, very powerful language for doing machine learning or whatever advanced concepts. So data mining, there are a lot of tools available. Earlier, we used to do it in Excel itself, Microsoft Excel. Now, the Microsoft Excel itself is built in with a lot of machine learning algorithms or data analytics algorithms. So there are other tools available. We'll see later on. Then features, labels, models, accuracy, and precision. So what is data mining, first of all? These are some of the algorithms which are very traditionally used. Very popular is support vector machines. Then K-means it's a very, very basic algorithm. Okay, so then a priori, expectation maximization, page rank, ADA boost, and all those things. So what is a data mining? Okay, data mining is a process basically during the machine learning, and then actually it uses the tools to extract the patterns which are there in the data set. So data has now become information, and from the information, or information is in the form of a data set, and from the data set, you are extracting the knowledge. Knowledge is nothing but your pattern. Okay, when you are extracting the patterns, then you can build a model. Okay, the model can be learned using patterns. So what are features? Features are basically the characteristics of the particular data or a record or whatever identity, what you call it as. For student means student will have a lot of attributes or characteristics. Student ID will be there, name will be there, gender, class, what are the marks, all those are features basically. Then what you want to predict is the label here. If you look at the table on the right, the features are basically size and age. The color is what I'm going to predict. So color becomes a label here. So the output thing, okay. So the features could be two things. One is categorical. Categorical, we don't have it's a fixed number of discrete values will be there. Okay, numerical values, when you substitute, instead of that, that becomes a numerical feature. Here there are a lot of categorical in the table, small, dotted, big, stripped, and all. These are all categorical data. Labels, I already told you. In the table, if you see, all these other, all the first thing, 5 columns are features. The last one is basically a label. Okay, so label will give you the class basically. Label is nothing but a class. You are building this class for the salary. So that could be, if it is a numerical value, that's very fantastic. Okay, we can build models like this. Now, usually international standard is when you are collecting data, you separate it into training data and testing data. Usually 80-20 principle is followed. So 80% of the data, you reserve it for training and 20% you reserve it for testing. So when you're building some models, you separate the data set. Why? Because when you feed in 100% of the data, then it is not at all learning. Okay, please keep it in mind. When you are collecting all the information and feeding it into the model, it is not learning at all. It becomes a lookup table. Okay, simple data. In earlier days, we used to do database, DBMS, management system, where you store, retrieve information. Now nothing happens. When you store something, you query the database, and it will reflect the outputs. So that's not going to be very useful because it doesn't learn anything. When a new unknown data comes, it will not be able to categorize or classify something. So that is the principle behind only using 80% of the data. Don't use remaining. So these are the parameters what you measure as an output. So you wanted to increase the accuracy and precision. There are difference between that. So accuracy is nothing but how close a measured value is to the actual value. So you can see the high accuracy will be in the middle portion, the second one. If you see the actual value will be the red one, but the measured values are closer to it. So that means it is more accurate. And precision is how close the measured values are to each. They are pulled together into a single cluster. You can see this left-hand side, so the first diagram. The third diagram, actually, it has got high accuracy and high precision. Okay, so that's the concept here. If you are building a model with a third category, that's very, very better. Okay, accuracy and ethics. Now, talking about machine learning techniques, there are traditionally, there are only three. Okay, supervised, unsupervised, and reinforcement learning. But nowadays, people are coming out with a lot of other improved versions of supervised and supervised. But basically, only three. So what is supervised is you have a supervisor. The algorithm is the supervisor. Okay, so there is a input data given, and the target is also given. Both input and output are given in supervised. In unsupervised, we don't supply the target. Okay, it forms the cluster. Usually in clustering problems, we use unsupervised. Then labels are made. Okay, so labels are not given in unsupervised. In unsupervised method, labels are given. Okay, labels, features, and labels are given. And reinforcement learning is something different. It's almost similar to supervised, but only thing is when the learning goes in the proper direction, then you reward. Okay, you reward by using an additional factor. Otherwise, you punish the learning process so that it does not proceed further if it is deviating from the type. So supervised learning, you have classification and regression problems. There are a lot of applications given here. I don't want to read out all those things. Maybe this PPT can be shared and then they can learn it. Unsupervised learning will be the dimensionality reduction and clustering. These are the problems in unsupervised learning. A lot of other applications are given. And reinforcement learning, you can ask others to mute, madam, audio. Okay, reinforcement learning. The robot navigation is a problem of reinforcement learning because we don't know the end target. We have to navigate and find out the targets. Okay. So classification problem, very beautifully explained here. It is nothing but finding the discriminant rule itself. So what is the discriminant rule? We have to find using the model. Okay, then you fit it. Okay, that is the classification problem. So you can see two classes are there. One is a red class and the other one is a blue class. You try to find out this line so that it will separate the classes. Classification example would be like classification of these images or faces or biometric fingerprints. Okay, all those things are classification problems. You wanted to find out who is this among all these chaps. Regression is actually fitting a line. Okay, it is actually finding relationship between input and output. So that is a function is given, and then from the function you are trying to find out you fit the line. If you see, all these data points are now lying closer to the line. So we find out a line which actually maps all the inputs and outputs. So it is a regression problem. This is a very good example. When you're able to see the first diagram on the left, what is the temperature going to be tomorrow? So that is a regression problem. Okay, so that means it is a continuous function. Okay, and what will it be cold or hot? It is a discrete problem. Okay, there is a classification problem. So anything which has got yes or no or 0 or 1 kind of stuff, it is called classification problem. Okay, you can also have multiple classes. Here I am putting you only 2 classes. But regression is nothing but it's a continuous prediction. So that is what is written on the top: discrete prediction and continuous prediction. Okay, so that is the difference between classification and regression. Clustering is something different. We use unsupervised methods for clustering. I'm just figuring out all the, I'm just drawing some lines so that I can cluster the similar points. Okay, so this is what is this. Actually, if you see this diagram, this is a satellite image. From the satellite image, I'm clustering all those buildings. These are settlements. Okay, red portions are the settlements or the buildings. Maybe yellow portions or some green, some grasslands or anything. Then blue is an ocean or something. So we try to categorize based on the category what it belongs to. So remote sensing satellite image, we are trying to cluster them. Now coming to the fundamentals behind machine learning, why all these learning, everything is happening. There is a fundamental actually. Actually, it started late in 1940 from the very basic model called the McLeish and Pitts model. It's a very fundamental model. They actually simulated logical functions. I think you would have heard of AND gate, OR gate, and NOR gate or XOR gate. They actually wanted to simulate the gates using artificial neuron. Okay, so biological neuron is like this. What is a neuron? Neuron is a very basic cell which is only present in your brain and spinal cord. Okay, only through that signals are being passed from various parts of the body. So brain consists of neurons. Neurons are very special cells. So it has got cell body, dendrites provide input, axon provides output, the nucleus is the actually storage thing. So this has been simulated as an artificial neuron on the bottom. If you see inputs, there are n inputs are there. Then one output is there. And actually artificial neuron has got 2 functions. Okay, 2 functions. One is an adder function. The other one is an activation function or threshold function. They call it as. Then there is also a bias. So this can be mapped like this. You can use a lot of activation functions in this place. Okay, so this is a simple artificial neuron. We call it as perceptron. A lot of inputs are coming. There is one more input is coming called bias. Bias input is always 1. So you sum it. So the adder function will sum all the inputs and inputs and weights. Weights are, W is a weight actually. Weight is nothing but a multiplicative factor we apply in order to strengthen the signal. Inputs are X1, X2, and Xn. They're all the input signals. When the input signals are weak, we multiply a weight factor to strengthen the signal. That is what we are doing. You're taking the sum of products here. Okay, sum of Wi, Xi. Then it is squashed using an activation or a threshold function. That is producing an output. So this is the process of neurocomputing. Take all the X values, use the weight values, multiply and bring out an adder thing. These are the very popular activation functions used. Linear function, the net sum which is received is the same output what you get. Okay, that's a linear. F of x is equal to x. Okay, or here it is shown as phi of x. Here phi of z is equal to 1 by 1 plus e power minus. So that's an exponential function. All the outputs lie between 0 and 1. Okay, so it's a very fantastic continuous function. It's called logistic function. Then there is a threshold activation function. What do we call it as? We take the sum sign. If x is greater than, or x or z here, z is greater than or equal to 0, we get 1. Less than 0, we get minus 1. So it's a threshold. Threshold in the sense it's a square, or it is a simple step function. And then hyperbolic tangent function is also there, tan hx. Okay. So this is similar to your exponential. Only thing is it is on the other side. Now, just to touch upon why we are going for neurocomputing, that's a fundamental behind machine learning. It is a connectionism or a very, very highly connected network, because this is how our brain works. There are a lot of cells, they are very, very, very parallelly and distributedly connected. We are learning that. Then neural computing is not programming, but it is a training. The learning happens only through training, not by programming. Okay, programming, we do it in the not traditional way. And very, very distributed memory is there. So memory is purely distributed. And it is capable of adapting to new environment. And it can also generalize. See, human beings are very good in generalization. We learn something. Suppose we see something which is almost similar to the learned thing, we try to generalize. Okay, something like we have seen this person somewhere and somewhere, so we are able to recollect something. That's called generalization. Then non-linearity. The function is actually a non-linear thing, which is done by neural, and robust, very, very robust in nature. This I already told you: supervised, unsupervised, and reinforcement learning. Supervised will have a class, a teacher or an algorithm where inputs and outputs are present. Unsupervised does not need a teacher. Teacher in the sense the targets. Targets are not given, only clustering is done. And learning from mistakes is very popular. Reinforcement learning is very, very popular nowadays in IT industry. Even a lot of students are doing project in this. So reinforcement learning is the best method apart from supervised or unsupervised methods. This is what is this. You have a model, you calculate the error and propagate the error backwards, and then train the model again and again so that it becomes perfect. So this error, the target minus output, is the error, which is actually feeding back. So that means it is fed back using a teacher signal, or so that is a supervisor. The supervisor is the error which keeps tracking. But in unsupervised, the corrections are made within the layer itself, and only there is no external factor. It actually clusters the neuron into different clusters. Reinforcement learning, I already told you, there is a reward and punishment for all the signals, whatever the actions. It's similar to unsupervised. When the error is going in the right direction, that means it is decreasing. Then you try to reduce the error by rewarding. Now, what is the difference between machine learning and deep learning? Very beautiful diagram here. Machine learning is, earlier days we used to do, actually in machine learning, we do the feature extraction separately using a lot of algorithms. Then you feed the features into the model, and the model will classify and produce an output. Okay, suppose there is a car, features are extracted from the car, they are fed to a model, pre-trained model, then it will identify whether it is a car or not for the unknown pattern. So that's machine learning. Deep learning, if you see, the feature extraction is done by the model itself. Okay, it is built into the model. That's why it is very popular. Deep learning is very popular because it has got the feature extraction built in within the model itself. Okay, so very fast and large data sets can be done. If you see one typical example of deep learning, the picture of a woman. So the first inputs are the visible layer will have all the inputs. Then the edges are categorized in the first level. Then the corners and contours are captured in the second hidden layer. Then the object parts are picked here. Okay. Then the final, so different layers are there. That's why deep learning. Deep means there are a lot of layers. That's why it is called deep learning. Then finally, it will identify whether it is a person, a car, or an animal here. Okay. So this is called deep learning. So in short, deep learning will have a lot of layers, and it's very, very complex, and it does in different levels. These are some of the machine learning methods. So a lot of so decision tree. I'm not going to the techniques here because everything is coming as a package nowadays. You don't have to just learn the fundamentals and use the package in Python or whatever language you are using. it will do all the job for you. So decision tree, decision tree, naive Bayesian and support vector machine are the supervised. For unsupervised, you have PCA and K-means. And semi-supervised, you have generative model, self-training, and support vector machine again. And ensemble learning, neural network, instance-based learning, a lot of methods are there. Depending on the problem, what you have, you can choose the model here. Okay. So you have to be very careful in choosing. So whether the problem is classification problem, or is it a regression problem or a clustering problem? First you decide that, then choose the model here. You look at this. Suppose there is the problem is actually fraud detection. If you are doing some project in fraud detection or email spam detection, diagnostics of some disease, image classification, all these are classification problems which comes under supervised. Regression, if you are doing some projects in risk management or score prediction, they are all prediction problems. It's a regression kind of thing, again supervised. Okay. And unsupervised is dimensionality reduction, face recognition, image recognition, text finding. They're all dimensionality and unsupervised. City planning, targeted marketing are clustering problems, again unsupervised. Reinforcement, robot navigation, gaming, finance sector, all these things are. So you have to choose the problem for your project, then decide about what type of learning it is, then choose the model. Okay, the models are already there, built in. This is again, see on the bottom, if you see, suppose you are doing a project in house price prediction, it is a regression problem. Okay, then it is going to use what type of variable? Continuous target variable, and it is an unsupervised. Similarly, for example, randomly I'm choosing market basket analysis. It is an association problem. Okay, target variable is not available, it's an unsupervised. Similarly, medical imaging, if you see, classification problem. It is not a regression problem, it is a classification problem. It is using categorical, because the imaging will have a lot of categorical values, not numerical values. That's a supervised. So typically you have to select something. For example, banks. Suppose you are applying for loans in a bank, they don't immediately sanction the loan because they check a lot of things. Whether you are a reliable customer, have you paid all the loans and other things. So that is a risk management. It's a typical classification problem. Similarly, if you see, I want to predict the stock market thing or the dollar exchange, whatever it is. It is a prediction problem. Okay, so that it varies. Similarly, mortgage. For for the property, you wanted to analyze whether I can purchase a property in this particular location, what is the age of the property, and what all the lot of factors are involved here. It's a clustering problem. Okay, take all the parameters, cluster them based on the area in which you are going to invest, then do that. Then after clustering, you can do classification. Okay, that is also done sometimes. Now coming to the model, how do we build machine learning? So you have features. From the data, you collect all the features, extract the relevant features. Then the modeling is actually a three-step process. So first you build the model, evaluate the model, then optimize the model. So it keeps on going. Then you can use it for prediction. So this is how a model is built. Select the features, separate into training and testing data, and also reserve something for validation. See, that is the difference between this training, validation, and testing. Training is basically learning something. Okay, you are learning through models, and trained results are coming. Validation is actually you are fine-tuning the parameters. If you see the model is actually there built, then you are validating the result and fine-tuning the hyperparameters. Okay, that means you should reserve some portion for validation. Then testing is to assess the performance. After the model is built, you can test using the 20% of the data and analyze the performance. Then how do we evaluate models? You can evaluate either offline or online. Okay, offline in the sense you are building a model, then using testing results, validation results, everything. Then you fine-tune the model and then do the evaluation, whether it is going perfect, accuracy, precision, everything is perfect or not. You are doing it offline, okay, without any real time. When after deployment in the where it is being used, Then you do an online evaluation, because a lot of factors will be involved when you deploy. When you implement in some place where it is needed, you will come across a lot of problems. Okay, so those problems you can evaluate and then retrain the model again. So this is model evaluation. The third step is optimization. Once we understand the model is not perfect, or it needs more accuracy or more things to be done, we can apply optimization algorithms. There are a lot of optimization algorithms. For example, ant colony optimization, genetic algorithms, okay, bee colony, or very popular algorithms are now available, optimization algorithms. Okay. Now, typical applications. For example, this is a character recognition. You can have a model like this. Okay, I wanted to categorize 26 characters. Cannot categorize. I wanted to classify them into either A or B or C up to Z. So the 26 will be the maybe the nodes in the output layer. Inputs could be the binary bit values, and I will have a lot of layers, hidden layers in between. I can build a model like this. So your number of inputs could be 64, because there are 64 squares in the image, and your hidden could be 16. See, there is no hard and fast rule for hidden layers. You can extract, you can have a ratio between 64 and 26 and fix the number of nodes. Face recognition, again. Okay, so this is a typical application where morphological image processing or even color-based, everything can be done in this. Then intrusion detection, very popular. A lot of student projects are now being done. Intrusion detection, where again you have to look out for the signatures of the whether it is an attack or not. We have to categorize them and then find out whether it is an attack. So it is basically an unsupervised problem. Okay. Learning the trajectory of the objects. Okay. So you can model it using a statistical model. So again, from continuous observation of long image sequences. So you have to take out a lot of images, because videos are very difficult to do, but people have come out with deep learning solutions nowadays. But when you take image wise, because every video, every frame will have 16 to 24 images, you can pick up those images and then see how far sequence of images are different, where this man is moving, kind of thing can be predicted. Lip reading, again, it all depends on how do we fix the features here. There is some logic used here to fix the features. You are picking these points, okay, simple knot or a control knot or whatever it is. Okay. The machine learning algorithms, only thing is, see, first of all, you should understand the data first, where it is coming from. That's why data science is very popular nowadays. Analyze the data, where it is coming from, why it is coming. You ask questions. Okay. After that, you try to analyze the feature. So feature itself is there is a separate course on feature engineering. Okay, feature there's a separate book also called feature engineering. It's not simple. Just like that, you cannot extract. So you have to understand the data behind that and why it is coming and how it is coming. Facial animation, very popular nowadays. Real-time target identification. Most of the in passport or the airports, they use it. Now let's go into some applications. It will be quite interesting. Please pay some attention here. Now let's try to understand two applications. One is on the cognitive science. The other one is disaster management. If time is there, I will also cover disaster management. So study of human cognition, emotion, and it's ML applications using brain-computer interface. Okay. So let me give you some fundamentals about what is cognition, emotion, and perception. So the basic building blocks for a human being is all your emotions are triggered by some perception. So perception is what you see. Okay, is not what you see. It is a higher level concept. Okay, what you see is not perception. After that, some intelligence you apply, then you perceive things. Then cognitive skills is, so you are applying something which is already there. Then you take some actions. Actions are, suppose for example, look at this picture. The man on the left is saying 4. There are 4 things are there. When you look at from this side, it is 3. So the way in which we perceive things, so from this angle, if you see, it is 4. From that angle, if you see, it is 3. But which one is correct? It all depends on how do we perceive things. Okay. So the process is seeing alone is not perceiving. It is a high level constant. Whatever happens between the occurrence of the stimulus and our behavior is basically your thing. Okay. So between stimulus and behavior is your thing. So it has got attention, recognition, and translation. Cognition, it is a mental action dealing with abstraction. Very difficult to measure, but again, there are processes available. There are a lot of levels actually. Cognitive process is not a simple process. It has got attention, memory, learning, language, reasoning, and decision making. All these things are involved in the cognitive process. Which one is more used depends on the emotion what you have in that particular. Okay, so your learning, experience, and cognition is a cycle. Perception and cognition. So this is a very good example. If you look at the first diagram, if I ask you which one is having a higher length, okay, which one is the length of the thing rod is higher. Actually, most of the people will say the first one because we perceive it to be a lengthier one. Okay, but actually both are having the same length. Okay. Similarly, the second diagram, if you see the length between the two circles, they're same actually. But when you put the circle inside, you see that the length is shorter. It's not. Similarly, here in the third diagram at the bottom, the length of the line is same only. So it is not actually a perspective view actually. So that is how, in what way we are seeing is the thing. So cognition will drive emotions, and emotion will also drive cognition. So it's a cycle. How we think and how we feel is emotion, and how can we change our emotions by changing our thinking? Yes. Okay. So emotion, the last one, is a 3-step process. So there is an action, there is a thought process, there is a feeling. Okay. So the feeling happens only after perception and cognition. Okay. So there is a physiological arousal. Something has to stimulate you. Then cognitive appraisal of the situation. You are applying something. Then outward expression is your feeling. Okay. That's what emotions. Let me give you one example. Suppose I show you one picture here, whether it is a male or a female. Okay. 80% of the people said it is a female. Okay. But when we change the emotion here, then people said, yeah, it could be male or a female. Because the way in which emotions are expressed in the face gives you a different perception. Okay. Earlier it was like they said it is a female. But the 70 to 80% of the people who said female here, only 50% said male or female. Okay, so that's how it is used. For example, this is another thing. Which smile is genuine and which one is fake? Okay, so you see, the left one is a fake smile. The right one is a genuine smile. How did you take a decision? Because the eyes, look at the eyes here. So A was fake because you have some zygomatic mouth muscles and also the eyes. Eyes are giving you some picture about this is fake and this is genuine smile. Detecting emotions in others. For example, there is a saying that introverts are better at detecting emotions and extroverts have emotions that are easier to read. So the extroverts, we can read the emotions very easily. That's what is this. For example, the example I'm going to show you is the same person. If you view it from the first picture, it will be like a fear. The man is having fear. But in the last thing, you can see it changes to anger. Please see this thing, animation. Initially, it looks like a fear image. Then it keeps on going and suddenly it changes to anger. So it is actually an emotion which is created by, okay, so within maybe a fraction of a second, it has changed. Okay. So it all depends on how do we detect this. So that's the thing. And all this happens in our brain. So we have to understand the brain things. So left side of the brain will control the right side. Right hand is being controlled by the left brain. Writing, language, scientific, mathematical, logic, everything is on the left. And this right side of the brain is actually controlling left portions. Okay, music, creativity, imagination, everything is on the right side. So right hemisphere and left hemisphere. So linear thinking and this thing. Okay, so we have to be very what do you call it as? We have to balance these two. Otherwise, it is difficult. You become more towards. You can see a lot of people are very good in mathematics. Okay, but they will not be very creative in nature. Okay, so that happens because there is no balance here. There's another thing. Emotions can be measured using balance arousal model. Okay, so balance in the sense something like if you see the next diagram, balance could be positive or negative on the x-axis. Arousal could be this y-axis, positive or negative. Arousal is you get excited. Okay, you get excited on the sad side. Okay, on the sad side, if you get excited, it is called tense, nervous, upset. The quadrant 1. Second quadrant is basically high arousal and high balance. That's a happy and excited state. The third quadrant is low arousal, high balance. That's serene, relaxed, and all. This is very better. The third quadrant is better. The second is also good. Third and fourth, sorry, 1 and 4 are very bad. Okay, 4 is very bad because low balance, low arousal. You don't feel anything. So Russell circumflex model is a very famous model. They captured all the emotions of the human in 4 quadrants. So you can measure the brain signals and capture the brain signals and understand a human which quadrant they are. And you can trigger some actions to move that person from one quadrant to another quadrant. That is possible. Okay, I can put a mobile app, measure your brain signals using the gadget, and I can do some action by playing some music or asking you to do something. I will change your emotion from one. That means from one quadrant to another quadrant. Suppose you are in quadrant 1, I will ask you, I will perform so that you move to either 2 or 3. Okay, that's possible. Now let's understand brain-computer interface with some applications of machine learning. If you watched the movie Matrix movie, that's a very fantastic application of what you call it as the brain-computer interface. And they do a lot of experiments with monkeys because monkeys' brains are similar to humans. They do with the ethical clearance, they do a lot of applications. Rats' brain are also similar. Okay, what they do is they inject some sensors and electrodes into the brain of a rat. Then they control the rat using the computer algorithm. So the rat actually moves like this, climbs the ladder and other things, but actually it is not doing on its own. We are controlling through computers. It's called rat bot. So BCI is basically, actually it's a very popular and very developing field nowadays. A lot of projects and research is being done. Why? Because we need these gadgets. We wanted to, a lot of people are now suffering from a lot of diseases, mainly psychological diseases. So we wanted to repair the cognitive and motor functions. A lot of people are getting Parkinson disease or they are losing, strokes are coming. So we need some solutions from BC. So that is the purpose of BC. BC is nothing but you put an electrode. Actually, we are not supposed to open the skull and put the electrode here, but a lot of gadgets have come nowadays. So the sensors are there. Nowadays, IoT sensors, everything is available. So we can place some sensor and record the brain signals. Record the brain signals actually from the skull, not from the brain. Okay, you cannot do it. When you touch the brain, the person is dead actually. So this is how, there is a helmet kind of thing or a cap will be there. We take EEG signals. EEG is nothing but electroencephalogram. Okay, ECG is for heart, electrocardiogram, and EEG is a encephalogram for your brain. Pre-process, feature estimation, feature classification. So this is a machine learning approach. Then you get the feedback and then do this process. There are techniques, invasive, partially invasive, and non-invasive. Okay, invasive techniques only the doctors will be doing it. But non-invasive, we can do it now as nowadays the gadgets are available in Amazon itself. We can purchase and then use it for our applications. So non-invasive technique is the electroencephalography. That's the last one. If you see non-invasive from the scalp. Scalp is a skull, what you call it as. The other things we cannot use it because they are all medical things. EEG, of course, only with the help of the doctor we can do it. But nowadays EEG, small game playing gadgets have come nowadays. So that's why we are using it. So what is EEG? EEG is actually a device which measures the brain signals. You know, the brain signals are categorized. Actually, brain generates these 6 waves: delta, theta, alpha, mu, beta, and gamma waves in the spectrum of 0.5 hertz to 30 hertz. Okay. So these things can be measured. This is one of the in our laboratory where we have a setup. This is a typical EEG device. Actually, with the doctor's advice, we cannot do it. These are the electrodes placed here. Okay, so all these electrodes are placed in the skull. If you see, there's a person lying, and the EEG device they are connected. So then there is a software which measures the brain signals. Okay, so we have typical environment there. We do also have these devices which are available in Amazon. You can very well purchase those who are wanted to do some projects in machine learning with EEG. This is called a Mindwave mobile or a NeuroSky. Okay, Mindwave. It has got softwares. It will give you, if you connect, you can connect it through Bluetooth to your mobile. There is a mobile app coming up. The EEG ID is a mobile app. Directly you can connect it without anything, and then you can do some activity there. You can wear it just like a headband, and then perform all these. So all the values are given there on the bottom. If you see, alpha, beta, and gamma values are coming here. So all these are all the values. So these values can be pre-processed and use it for machine learning. Very fantastically we can do. Okay, because all you get excited with the values. There is another device called EEG Emotive. Emotive is 16 channels. You can see all the green things. It will cover all these portions of the skull. Okay, so that means you are getting some values from these portions of the brain. There's also app which is coming along with Emotive. There is another band called Muse band. Okay, which is actually purely for tracking your day-to-day activities and meditation activities. So these are some of the things. Now, these are the portions of the brain. I don't want to go into the depth of it. It will be boring for you. There are 4 lobes actually. Frontal lobe meant for your cognitive motor activities. Parietal, and then occipital for visual, and temporal for hearing and other things. You can mute other things. Can I continue, madam? Hello.
Yes, sir. Yes, sir. Yes, sir.
Yes, ma'am. Yes. Okay, thank you. So these are the various lobes and what are the activities done by them. Okay, so when you want to perform something only with speech, you can only apply on the frontal. You can take measurements only from the frontal. So there is these are all the international standards. They call it as 1020 standards. You can put all the sensors here, and it will measure. Okay, the left side is called odd numbers are called left side, and the even numbers on the right side. This is how it looks like. Okay, so you can put all the this is a prefrontal area, FP1, FP2. There's frontal area, central area, parietal, occipital, and temporal. Temporal on the ear side. So all these points, you can put electrodes and then measure it. So in early days, we used to put electrodes at every point by applying paste and other things. Nowadays, gadgets have come. That's why it is very, very easy. These are the signals which are generated. So delta wave is actually when you are sleeping, 0.5 to 4 hertz. Theta wave, you are dreaming, but you are not fully in sleep, but dreaming and you are a little awake. Alpha is when we are relaxing, when we are talking. Say we all now generate alpha waves because need not be closed eyes, but we are being relaxed. So alpha or mu we will be generating. Beta waves when we are doing some critical activity, little tense. Okay, you can generate beta waves. Gamma waves is very, very dangerous. because it's very stream of consciousness. That means you are even more tensed. Okay. So in watch which waveform you're generating will tell you what emotion you want. That is what I wanted to tell you. This is an untrained beta wave. You can see the portions. This is again picked up from the software. You can see randomly on the back side, occipital side, there are a lot of generation. When I ask the subject to do a particular activity, it is trained. Then you see it is focused only on the one portion. Earlier it was actually two portions, and now it is focused. So that means I can train. You can see a pattern here. In the trained graph, there is a pattern here. Pattern means some similarity is there, not in the first one. Similarly, beta waves, you can see in the first waveform, there is no pattern. And the second, there is a pattern here. So this pattern can be picked up for some applications. Okay. And there is another popular thing called P300. P300 is nothing but potential difference at 300 milliseconds. See, the values will come from these portions, FZ, CZ, PZ. Why? Because, see, when I look at some object, the brain recognizes that to be the object. I name that object by the brain. It takes 300 milliseconds for doing that. From the eyes to the brain and recognizing an object takes 300 milliseconds. That is triggered in this portion. That can be captured. Actually, that can be captured to spell. It's called speller paradigm. That means I ask you to spell some words. Suppose, let's say God, G-O-D. G-O-D, I should not spell out with the mouth. I have to spell out using my mind or thought. So whenever G is blinking, I will say G in my mind. O is blinking means O in my mind, and D. So that means G-O-D has been spelled. I take the signal in this portion. Then I can create a word processor, type out what you're thinking. That's a very fantastic application which is still being developed. See, very useful for people who are paralyzed. Those who don't have the ability to move their arms or legs, only thought process is there. They can type letters using brain. Okay, that's the thing. So this is a NeuroSpy software what we use in our laboratory. It's customizable. We can customize and then take the readings. You got all the readings. You can change the map like this. All the parameters are available here. I'll show you some case studies. See, one of the students we put the subject, we called him as a subject, and we asked him to listen to the music file, meditation.mp3. So after some time, he was generating alpha waves. So I could see the alpha wave because, see, look at this, C3P4. That means C means central, P means parietal. So that means on the parietal lobe, he was generating alpha wave. How do you know it is an alpha wave? From the frequency, I can predict. He was generating alpha wave. That means he is relaxing. He is listening to the music. He is relaxing because that's why it's generating alpha wave. Second example, just by blinking the eye, if you see there's a blink happening in the FP1, F7. Okay, that's a potential difference between these two channels. Okay, this is a channel. Every line is a channel. So on the prefrontal side, when I blink, something happens on the positive side and also on the negative side. See, that means it could be used for switch applications. I can switch on the light, off the light. Okay, on off kind of application. I can use it for blinking, eye blinking. So it is again, that's something. The third one is, I asked the student to calculate sum of first 1,000 natural numbers. So that means the formula is n into n plus 1 by 2. So he was calculating 1,000 into 1,001 by 2, all those values. So critical beta waves are generated. Okay, again on the prefrontal. Then cursor movement. So imagine this ball to be the cursor. I can move the ball by thought process to the left or right or up or down. Okay, that means you can pick it from the C3, CZ beta waves. I can move the ball. Ball is basically the mouse cursor. Okay, I can use it for applications. So like this, you get a lot of values. Each column is a channel. When you plot these values, you will get a graph like the previous one. So these kind of graphs you will be getting. But as a machine learning expert, I need only values, not the graph. So these values, I take it, feed it, pre-process it, and feed it into my machine learning algorithm and do the classification or prediction. There is another example called music therapy. Music induces emotion in the human being because a lot of relaxing is happening. So we can use music there. We're using the valence arousal model I showed you. Okay, this is the thing. Melody music. See, this is one typical experiment we did. He was asked to listen to melody music. You look what they think. Very beautiful, like a delta wave, almost like a delta wave is being generated. Devotional music, some theta. This is the activity actually. If you look at this, 0 to 6 minutes. What are the activities done? Okay. Initially, after 15 seconds, he started generating very intense beta waves, excited tension state. Then immediately after 1 minute, we played a soft melody music. So he was generating alpha wave. Okay. Then we changed the music. Okay, change the music to a devotional music. Then he was generating low frequency theta. That means almost like a delta wave. Okay. Then high frequency, when we change the music to rock music, you can see he was generating a beta to gamma waves. That's very dangerous. High frequency. That's very dangerous. So like this, the values are picked up and we can apply to machine learning. Brain browser is our current project which is going on in our laboratory. We wanted to use brain for browsing. So this is a typical how the gadget is being done. If you can connect it to any iPod or mobile or apps or anything, you can do something. So brain browser will work with the blink model and think mode, something like this. We display some icons. We ask him to stare at one place or just blink. Okay, you have to just blink your eyes when you're staring at this place. The values will be picked up. And which one you wanted, sports or movies or music or whatever it is. Again, icons. The colors will be changing. Whenever the color changes, you have to blink. Okay. See, the guy has blinked in movies, and again, science fiction movies, he has blinked. Then all the websites related to, again, it goes as into the browser. Okay, the Google search engine, and all the websites relating to science fiction movies are listed. Then you can also scroll, because see, I'm not using the mouse. Scrolling is also can be done using thought process on brain. So it's all possible. Very useful for people with paralysis. Then we also developed a mobile app for measuring the yoga, effect of yoga on meditation. Okay, all the yoga portions were pumped into the mobile app. What they have to do is they have to perform yoga using the mobile app and also the gadget. You have to wear the gadget and then do it. So after some time, if we find that all relaxation coefficient, we measured almost 12% is relaxed. Earlier it was 46. Now it is better. 58 relaxing coefficient is increasing. So we have a proof of concept that yoga induces some activity in the brain to relax. Okay. Similarly, we did a project in again machine learning application using BCI for wheelchair movement. Real wheelchair was moved. We had a GUI like this, and again brain waves are captured. We have eye blink model and concentration model. You can concentrate and look at the particular icon, or you can make a blink. There are two modes. Look at this. The icons will be blinking. Okay. Whenever you wanted to do something, you wanted to move left or right, you have to blink, or just stare at this place. The thing will be moving. Okay. Then we did one more application in color. There is a relationship between color and blood group. So we wanted to prove that relationship. We showed these pictures to the students. Almost 100 students we showed it and asked them to just feel relaxed while looking at the pictures for just 2 minutes. This was the results we got. So those who are A positive, A group, blood group, they were actually relaxing during blue color or green color. Okay. So, but these guys, again, O positive, they were also relaxing in blue rather than green. So this is another thing, typical thing. What we concluded with only the 100 subjects was blue color, the people with these blood groups, A positive or B positive or O positive, they are getting relaxed. Green color, P positive and O positive, they like. Why they are relaxing? Because they like. That's the meaning. B negative, yellow color, they are getting relaxed. And very surprising, A positive and AB positive guys also get relaxed in red color. So that was a finding. Actually, this is not a 100% proof method, but only with 100 subjects we did. We had to expand the research more, then find out the relationship. Other applications, like you can do all these game playing, making a phone call and other things in. The Parkinson disease, there is a solution actually still being evolved. You can inject a neural or a BCI small device into the bloodstream, and it will inject medicines whenever there is a seizure. The Parkinson disease, there is a solution. Lie detection, BCI is a typical, because the brain does not lie. You can lie through your mouth, but you cannot lie through your brain. Brain activity, you can capture and find out the guilty. Yes. Okay. Silicon cognition is the next level. Okay. So when something motor imagery thing is not, actually it is not done, restoring the memory using silicon chip. So that's a future thing. Maybe I'll quickly go through the second application, disaster management application with machine learning. Very useful for guys who wanted to do some projects. So what is a disaster? See, disaster is you are destroying something which is already existing in the nature, or it is both natural and man-made. Okay, naturally we cannot do anything. Earthquakes, cyclones, tsunamis, and droughts, they're all natural things. Most of the natural things happen because of human activity. Okay, we are man-made. Man-made disasters are chemical, biological, radio, nuclear, and all. This is typically done by human error, but also this also induces natural disaster. Okay, so these are the typical statistics. Actually, you see the natural disasters have increased over the period of time. 1970, it was very, very less. But look at this activity, very, very dangerous, because in 2002 to 6, very big. Now at least little bit reduced. See, all this happens because of human activity. We do a lot of disturbance to the nature. So that is why we get a lot of things like this. See, there's a statistics again, I'm just showing you. 58% of the land of India is prone for earthquakes. Very dangerous to see. And 40 million hectares are prone for floods. Again, statistics, very dangerous statistics. 7,500 kilometers on the coastline is prone for cyclone and tsunamis. That's very. And similarly, 3% of the mass, total mass, is landslide. It happens on the Himalayan region. It's all available. Okay, the data from the natural disaster. So there are gadgets available. Before doing machine learning, you should collect data. Okay, for disaster management. Very, very huge data. See, big data application project is this one. You have a lot of data from the seismographs, geophones, occurrence of earthquakes. We can build solutions. You see the fourth one, displaying in browser and doing some analysis. We got softwares available. Okay, so a machine learning solution is possible using this. You get a numerical form like this. After this, then the fifth one will be applying in the machine learning. Then from the UAV, see where people cannot go, like in disasters like earthquakes or chemical leakage of the plants and other things, where humans cannot go inside, you can fly an UAV, unmanned aerial vehicle, and collect the data. And you can also develop some machine learning solutions. Remote sensing, again, see, this is measuring from the geophones or GPS satellite. Okay, so GPS available in your phones, you can measure the activities. Landslides, from satellite image only. We cannot apply this normal GPS and other things. But to some extent, GPS and satellite images only will play a vital role in landslide. So you look at this, it is again machine learning application, it is possible. In case of tsunamis, see, there are a lot of geophones and gadgets deployed nowadays. After the tsunami earlier in 2004, after that, people have developed a lot of solutions now. They are now deploying a lot of gadgets and measuring all the activities. Okay, now they got a lot of GPS based and geophone based gadgets which transmit a lot of data to our tsunami warning center. Okay, that's possible. These are some popular websites which provide data. because as a student, as a researcher, when you want to do some project or research, you need data. Okay. See, normal image processing and other things, you can collect data from everywhere. But what about disaster management? Okay. So you have to collect from reliable sources. These are some of the sources. You can note it down. Otherwise, I will share it. USGS. Okay. It's a US based. They pump in a lot of remote sensing satellite data. United States Geological Survey. Then VEDAS. That's a national disaster data which is available. It's an Indian website. So it's a spatial data which is given. Then EMDAT, it's an international data, it's disaster data. It gives a numerical format. You can collect the data. See, huge amount of data is available. Satellite image is not a simple image. It's a hyperspectral image. So that data, we have to apply big data tools, apply machine learning. If you are developing solutions, that's very, very fantastic. Not much work has been done. See, in India, the biggest problem is computer science people are working separately and civil department people are working, or geospatial people are working separately. If they handshake and work together, it becomes an interdisciplinary project and very good solutions can be built. These are another survey of India. That's another website where you can get data, topographical data. Geological survey of India, geological, okay, hazard data, national disaster map, thematic maps are there. These are all, some of them are very, very freely available. So that's a very thing. I think for the machine learning community, Kaggle, okay, those who don't have a login, please create some login in Kaggle. You get a lot of data sets for machine learning projects. And also you get code and also help. There's a community there. You can post questions and they will help you a lot. Okay, so please register in Kaggle apart from the GitHub and other things. So then data.world, I'm just now giving you something for disaster data. Data.world, there is a website. Then data.gov, it's a government thing. A lot of, again, disaster data, natural disaster data, everything is available. CDAC, it's a American kind of thing. Okay. So all these, again, FEMA data, Federal Emergency Management Agency, they have a lot of data sets. See, from these sources, you can collect these data and use it for your applications. This is for data disaster management. Second application, what are the tools? So you have to rely on IoT, okay, sensors. Very, very popularly nowadays use social media. See, in Twitter or in Facebook or whatever media they are communicating, they are collecting a lot of information. Those streams and tweets they are taking and they are analyzing and doing. A lot of NLP is being done. Natural language processing is done. Remote sensing, geoportals, all these are data sources. What are the components we are going to use, and the technologies what we have been using in disaster management, 4G or LTE, then satellite communication, ZigBee, low range connections, okay, ZigBee, Bluetooth, LoRa, okay. Then what are the parameters we will be measuring, and this is the analytics, very, very useful for you, okay. NLP is used in social data analytics. Deep learning is used in sensor or textual data. And convolutional neural network is used in image, video, and spatial temporal thing in geospatial. The objective is given here, and so this picture will give you a holistic view of what are the big data tools and IoT tools specifically used in disaster management, but again, it can be used in any other. Please learn these things. Okay, this is a typical big data machine learning technologies being used nowadays in the market. Current thing which are there because very, very popular and very, very powerful, okay, because they are all working in distributed environment. That's a very fantastic. See, machine learning, they have Mahout, which is actually a scalable machine learning. That's why people use it in distributed. Spark, MLab, it's a library of machine learning. Then distributed programming, they call it a MapReduce, scalable programming paradigm. Pig is a high-level scripting. Then Hive is a data warehousing kind of thing. Then Spark, all these things are people are using it for distributed. Then Hadoop Beyond, to split the functionalities and resources you are using. This is a resource management tool. NoSQL, see, nowadays people are working only with NoSQL because you don't need any structure. for a query or whatever it is. You can store any type of value, any structure. Okay, so it's a NoSQL kind of thing. Then HDFS, it's a file management system. Then Woozy workflow. It is actually the action diagrams. You can visualize it as a flow diagram. Then Zookeeper to coordinate everything. And then for data exchange, we use Scoop. So all these are some very, I think many of you would not have come across these, but please learn these terminology. What is that and what is this? These are all some things which are used currently in major projects, major in IT related projects. At least you try to learn Mahout, machine learning, and Spark in your project. Okay. This is a typical smart city where IoT based or big data based solution can be provided. Nowadays, our country, our Prime Minister is also speaking about digital India and also building smart cities. So here, if you look at this diagram, see a lot of smart building IoT devices are deployed. Then we transmit all those sensors through these protocols, WiMAX, Zigbee, LTE, and all. Then it is harvested and then use it for data analytics and data management. Then you can take some decisions. Okay, only the machine learning will play a role. You also have smart transportation to avoid this kind of thing. Then crowdsourcing, where the crowds are more, crowdsourcing can be alerted so that some disaster could be smart homes, satellites, everything. See, everything put together is the smart city here. We did a simulation model. I will just show you 3 or 4 slides where, see, we have a remote sensing data, we have a seismic data, geophysical data, geological data, petrological soil data, or geodynamic data. All these are fed to their neural network model, and we all actually analyze the less damage or moderate damage or heavy damage. So what we did was, we took all these parameters from various sources, chemical reactions, pressure, altitude, presence of dams and oil reservoirs. And we wanted to predict how much people will die when some earthquake or tsunami happens with a particular Richter scale. We call it as the earthquake impact analysis. So this is a picture. This is a what you call a GUI. So I have to select the country. I have to select the zone of the country. What is the magnitude of the earthquake which will strike? I'm just predicting. I will put some 8 or whatever it is. Then what it will do is, it will analyze the data which is already available, and then will find out how much is the population already there and how much people will die and what is the. So we apply genetic algorithm and we run this program. This is the estimate which is done. See, this is for one of the area called Jammu Kashmir. Let us say the magnitude of the earthquake is 5. Okay, and how many people will die in this place? Okay, what will be estimated infrastructure damage will happen? See, these are all actually again picked up from the already available information. So that means it's a typical classification and also a clustering problem. So we can use the pre-data, already available population data, how many brick walls are there, how many block houses are there, everything is already there. But only thing is, we have to build a proper model to take all the parameters, and for this magnitude, what will happen? Similarly for sea data, tsunami. See, look at this, the same thing. The sea epicenter of the earthquake happens in the sea, which region and all. Then how much damage it will create for the tsunami. See, look at this. When something happens in the North Bay of Bengal, okay, so particular typical 5 hour earthquake thing, then the tsunami will hit in 15 minutes in India. Look at the bottom table. You can save 4 minutes. You can within 4 minutes you can save. So within 15 minutes you can the tsunami will reach India. So this is again from the data available. This also. So these are the typical data on the earthquakes, again picked up from the source. So that completes my presentation. But 2 or 3 slides, I have some tips and other things for you guys. See, there is a Gartner hype cycle which is released every year. So please type Gartner hype cycle in your Google. You will get it. 2021 is released. 22 is yet to be released. So what they do is, most of the companies, they look at this diagram. Then they invest based on this strategy, which is peaking. So it is actually given with the time and expectations. Even though it is called hype, but most of the things are happening actually based on this Gartner cycle. They release it. Gartner is the company actually. So what is the current technology which is being used or mostly peak in inflated expectation is AI augmented software engineering, non-fungible tokens, data fabric. These are all the things which are very popular now. It may again go down. Okay, trough of disillusionment, then slope of enlightenment. So when the technology comes in the slope of enlightenment, that means it has standardized and you get a lot of revenue from that. Even if you invest in these technologies in the upper cycle, you get a lot of money. Don't invest anything in the lower part. So even if you're choosing projects or doing research, you can choose this, which area I can do research. So it's a good indication of which is the emerging technology. Okay, so I ask you to just look at the Gartner hype cycle and decide. These are some of the research topics. Even it need not be a research, but again, project topics for in machine learning with the BCA. You can do color meditation. You can do emotion recognition, music therapy, brain browsing, study on the effect of yoga and meditation, then early diagnosis of brain-related diseases. You can have a study on reducing stress and strain, BCA-based target 2D control, robotic wheelchair, or onboard chess playing. All these are typical brain-computer interface with machine learning problems. You can choose any one of them. If you are interested, you can choose projects or research topics in this. Okay, so very, very powerful and also currently being used by people, BCI. Okay, and some of the trends. See, the current problem in the world is combating COVID. So COVID is the problem. So you can choose projects in COVID data. It will be a very big kit. You can get the papers published very easily, and also it gets attraction. Okay, you do projects in COVID data. Business forecast is another thing. Biometric security solutions. These are very, very popular nowadays. And AI has gone into different dimensions. One is automated machine learning. A lot of Azure tools have come. You can choose Google Auto ML also. You don't have to code anything. Everything is available. Okay, don't worry about models. Just learn the fundamentals of the models. Don't go into the mathematics of the model. That is not our job. In our days, let's see, 20 years back or 15 years back, we used to learn the code. We used to rewrite the code. Everything was done by us. But not nowadays. The current generation is not worried about anything. They are just collecting data, do some analytics, and apply the model which is already there. They are not developing any new model. Okay, so you don't have to do it because it's why to waste the time. Okay, so automated ML, explainable AI, very, very popular. Conversational AI, generative adversarial net scans, very, very popular. And convergence of IoT and AI is happening in industrial. It's called industrial IoT. Okay. So then AR, VR, very, very, very current problems. So a lot of solutions are needed. A lot of research is being needed in this area, AR, VR, augmented virtual reality. This is the last slide. So I request you the students to read a lot of books. First, read a lot. Okay, don't just imagine things and don't spend time in social media and other waste of time. Even if you are looking at social media, look at some very important technical articles, or when you're watching YouTube, watch some very good technical YouTube videos. And you can also do some MOOC courses. Online courses are available plenty nowadays. In Coursera, edX or NPTEL, these are all platforms where a lot of courses, free courses are available. You can register and do. You can learn machine learning, Python, or whatever you want, deep learning. Everything is available there. You can register and do. So don't believe everything. That's my second advice. Social media posts are people's perceptions are different. You don't have to believe everything. Put some analytics into it and then ask questions. Why not? That will give you some research directions. Look out for some latest technology. So invest some time and do projects in latest technology. That will give you a lot of name. So that's why I said you Gartner cycle will give you some indication. provide solutions to the current problem of the world. That's very important. COVID is the current problem, okay, or disaster management, or whatever you call it as. Okay, find out the current problem. And the last point is, don't waste time in collecting or using building a model or anything. Use others' intelligence or data. Data is huge. Data is there in the website. There are a lot of free Kaggle archives, GitHub, everything is there. Coursera. So a lot of others others have built a lot of intelligence. Make use of them. Okay, that's my very humble request, and that will lead you to a very good human being. With the latest technology, you are providing solutions. Okay, so thank you very much. Any other questions? I'll be happy to answer.
Dear students, please ask any query. Research scholars, please.
First of all, was it useful for you? Something was useful for you students?
Students, please. Research scholars.
Oh, research scholars are also there, madam. So maybe you can also share the screen to them. Sorry, share the PPT to them.
Students, please ask any questions. Shahid Kumar. Eseki Muttu.
Okay, you can take it offline also, madam. Any feedback form, if you want, you can circulate later on.
Yes, sir. Then, yes, sure, sir.
That you can share it with me.
Yes, sir.
You can collect it and then send me as a mail. Maybe I'll be able to reply.
Yes, sir. Yes, sir.
So hope it is useful for you guys, because a lot of research is being done in these areas. I just wanted to highlight, because I don't want to go into the programming or tools or techniques in depth, because everything is available and they can learn it as well. I just wanted to throw some light on what is the current trend and what are how to approach a problem and how to choose problems. That is why I just gave some advice during this.
Sure, sir. It's very useful.
I think many other.
Yeah, it's very useful to students, sir. Sir, because this our topic is brain computer interface is a big application for implementing in deep learning and machine learning, no? So here we have a little bit knowledge under that brain computer interface under in deep learning analysis. So it's very today it is all of our students and research scholars are well gifted for gaining our knowledge and sharing our thoughts, sir.
Okay.
So it's very useful to me and also research scholars also.
Yes, madam. Any help, if you want, you can share a mail or just shoot me a mail. I'll be able to help you.
Yeah, sir. Yeah, sir. Sure, sir. Can we conclude our session, sir?
Yes, madam. Again, yeah, I think I thank all the organizers and also Kalpana madam and the head of the department for providing me an opportunity to connect with my college. Sure, we call it as AKCE those days.
Yeah. Okay.
So thank you very much. I'll be happy to share even in future also anything possible. I'll be able to.
Sure, sir.
Thank you, ma'am.
Thank you, sir. Thank you. In vote of thanks, our honorable professor and my dear students, it seems to be a great honor to propose the vote of thanks to all who have helped us in making this workshop on our second day. Yeah, very resounding a success. First of all, I would like to give my heart vote of thanks to our research person, Dr. Sir Sridhar sir, for gracing today's workshop. Thank you, sir, for your very thoughtful, provoking and give a valuable information on machine learning, which involves in brain computer interface and structures, how it will be involved under the tool and how we can get a data and analysis based on EEG. In order to you extend the analysis in disaster management also. So it's very useful to us, students, and also to myself also. And I would like to extend our thank to our Professor Nagaraj Sir, Vice Chancellor, Kalasalingam Academy of Research and Education, and my heartfelt thank to the head of the department and our faculty. And also I thank to head of the department under in CIT, Coimbatore Institute of Technology, and Ayanada College of Ayanada Janaki Ammal College, Sivakasi, and its faculties and students for their valuable contributions, guidance, and encourage in all support in all and give effort to students to attend this workshop. And also I express our sincere thanks to all our students of our cooperation in making this workshop a resounding success. Thank you to all. Thank you, sir.
Thank you, madam. Thank you very much. Thank you, students.
Thank you, sir. Thank you.